Hello and welcome to today's Petrosys webinar. My name is Ewan Rule and I work in the UK office. The webinar will last around 15 minutes. It will be recorded and will be available to view shortly on the videos page of our website. The audience will be muted, but please enter any questions in the panel and I'll answer them at the end of the presentation. This is the second in our connectivity series and will focus in Petrosys mapping with Esri. We'll start by looking at key connectivity workflows. Using the Petrosys map canvas, it's easy to integrate live data from interpretation systems in native Esri data. From your interpretation system, you can display common G&G data types like shot points, interpretation, wells and faults. And from your Esri implementation, you can add in cultural data from both shape and raster data sources. When data is changed in either the interpretation system or in Esri, the Petrosys map updates. There is no need for data transfer, and this avoids data duplication and version control problems. Of course, there will be times when you do want to move data between your interpretation system and Esri, and Petrosys can help here too. Geoscience data types from interpretation systems can be written out to Esri formats, or Esri formats can be written directly into some interpretation systems, or converted to industry standard ASCII formats. And Petrosys will accurately convert coordinate systems if necessary. There are many places in Petrosys where it's possible to create Esri formats. Our Spatial Editor allows both the creation and editing of shapefiles and file geodatabases. Shapes, attributes, and individual coordinates can be edited using easy and intuitive tools. Petrosys also has a plugin for ArcMap, although we won't cover this in the live demo today. The plugin allows ArcMap users to add Petrosys grids, faults, and contours, which will display with good rendering and be available to them as native objects within Arc. The plugin also allows ArcMap users to run Petrosys Advanced Surface Modeling, giving access to both interpretation and Esri data as gridding inputs. There are other useful features which we won't cover in the live demo. The Spatial Editor also allows grid data to be back interpolated to Esri file types. For example, back interpolating a depth structure grid to a point feature class at well top locations, or back interpolating from a formation thickness grid to planned horizontal well bore locations stored in a line feature class. We'll now move into the live demo. Before we start adding Esri data onto our map, we're going to just remind ourselves about the connectivity Petrosys has with other applications. You can see that I've got data displayed from a variety of data sources on this map. We've got our well information coming from Dug Insight. We've got some 2D seismic data coming from a Kingdom project. This is in the coordinate system WGS84 UTM31. We've got data coming from Petrel, it's in ED50 UTM31, so we've got a datum conversion going on in here. And if we look at the extent that we've got displayed at the moment, you'll see that we're working in projection UTM32, so all the data currently displayed is getting coordinate converted. Now we're using a dynamic area of interest just now. I'm just going to move out to a larger area of interest and we'll add in some cultural information. So there are various ways we can do this when we're working with Esri data. For things like shape files and layer files, you can just drag and drop them into your map boundary. Now most data types like shape files will just display immediately. For the layer file, we're going to convert the symbology from Esri's formats into Petrosys' own formats, which will just take a second, and now you can see that's displayed on our map as well. So we'll just have a look through the options that you see for controlling this data. First of all, you can see the coordinate system information in the feature classes part. You can see what sort of shape data you're dealing with, and this has got geographic coordinates in ED50. The other thing is we're using a layer file, so you can see we've automatically imported the expressions in there so that all the different operators are being thematically mapped without any effort on the part of the user. And this is now in Petrosys' own native format, so you won't need access to the ARC license again. You can use all the different attributes for annotation. I've currently got the name switched on here for these different production licenses. I'll just switch that off for the moment. And you can also do filtering. So you've got access to multi-level filters here. You can either use an SQL filter or you can use standard filtering. So just as an example, we'll filter by the operator name here. And I'm going to scan for all of the instances of Statoil. This is an old shapefile from before the name was changed to Equinor. SAG is one of our previous versions, and I think that Hydro is also in here as one of our legal entities. So if we click that button and say apply, we'll see that we just get the Statoil blocks displayed now. As I mentioned though, it's a multi-level filter. If we just want the active production licenses, we can switch that on and that will reduce what's displayed. Or one last time, we can also filter by the actual round name. It'll be more obvious this time. If we just take those licenses from the fourth round, you should see there's only a few licenses that are still highlighted in the map. So you've got a lot of control over both how your data is selected and how it's displayed when you're working with shape data types. There are other ways to get the data onto the map. If you don't want to drag and drop, you can go to the display menu or use the icon here and select the display GIS option. Now, as well as shape files, you'll have access to things like ARC coverages, line point and polygon classes from ArcGIS web servers, personal geodatabases, but I'm just going to add in some data from a file geodatabase. As you can imagine, you can't drag and drop from the file geodatabase because there are a lot of different feature classes within it. We'll switch over from the Gulfax to our North Sea Culture geodatabase, and we'll add in some pipelines. So obviously we can have data in different coordinate reference systems and different shape types. And of course we could set up the thematic mapping here like we did for the license blocks. So we've got some polygon and line data displayed here from geodatabases and shapefiles. We'll put on some raster data too, and I'm going to choose a web map service. We'll cover web map services in more detail later on in the webinar series, but just as an example, we're choosing the Norwegian Petroleum Directorate's ArcGIS fact maps, and once you've connected up to this, you can see the different layers that are available, and I'm just going to add on the fields and discoveries in here with a little bit of translucency. Pretty much all the features and fills in Petrosys can be translucent if you choose. So we're starting to build up quite a nice map here. The next thing we'll look at is creating a surface using data directly from Esri. And we'll also have a look at moving data around between different sources. So we've opened up Petrosys Surface Modeling. For those of you familiar with this module, you can execute a series of tasks and build them up into a workflow. And you can also put the various steps into different groups. So the first step in my workflow here is creating a grid from data being sourced from Esri. Now you can have as many different data sources in here as you want to, so you could combine your GIS data with data coming from an interpretation system. You could have shape files and ArcGIS web servers in here if you want. For the grid I'm creating here, I'm just using an ArcGIS web service, and I'm going to take point data. In this case, it's going to be exploration wellbores. We just choose an attribute that's got a Z value, and then we can put that into the grid creation process in Petrosys. Once again, if your input data sources are in different coordinate reference systems, it doesn't matter. We'll convert the data to what you've specified to be your output coordinate system for the grid itself. If you were working in the subsurface and you had fault data, we don't only pick up fault data from interpretation systems, you can also include fault data that you've received as a shapefile. The second step in this workflow is to move the grid that we've created from the GIS data within Petrosys and to write it back into a Petrel project. So for the purposes of this demo, I'm working with ArcMap in Petrel. We can also put point line and polygon data directly from Esri data sources into Petrel. So I've picked up my shapefile with the production licenses here. For the filtering, I've filtered by the operator attribute. This time I've not filtered by the round name or the status. However, I don't want to write the production licenses for the whole of Norway into my Petrel project. I'm just interested in those licenses over the Viking Graben. So you can also choose to filter by an area of interest just to restrict the amount of data that you're writing into other applications. So there's a wide range of different input data sources you can use here. The Spatial Editor Translator is a very useful tool for moving data around and working with GIS data in general. You can see we're just writing this straight into the Petrel project. It will go into a new folder called Data from Esri. Only takes a second to run. And if we go into Petrel, down at the bottom we've got our new folder. Here's the item that we've written in. When we zoom out, you can see the blue irregular polygons are the production licenses. And we should also have all the attributes stored in the shapefile or the geodatabase have now been written into the Petrel project for the geoscientists to work with there. Moving back over to our workflow, you can also import grids into Petrosys' own format from various interpretation systems, and you can import things like fault polygons again using the Spatial Data Translator. You can pull these in from an interpretation system and write them into an Esri data type. Now, if you don't have access to our Arc plugin, you can import grids to Petrosys format and export them out to ArcASCII format. If you do have access to the Petrosys Arc plugin, then, as I mentioned, things like grids and faults are native objects. We can just pick these up and drag them into ArcMap, and it will take just a few seconds for the grid to be rendered. We could obviously change the color bar for it within ArcMap, but I just want to show you that this data is just going straight into ArcMap. It's a really easy way to get access to your geoscience data. So you can see the data is displayed in Arc. The grid is just a raster as far as ArcMap is concerned, and you can go ahead and continue to work with that with all your other GIS data types. The last thing we'll do in the live demo is have a look at the Petrosys Spatial Editor. This can be used to create and edit shapefiles or indeed geodatabases. I'm just going to take the faults that we'd imported to a shapefile from Petrel, and we'll make some edits to these. To start off the Spatial Editor, you can click in the icon to fire it off, or else select the layer that you're interested in and choose the Edit menu. Then drag the item that you're interested in working with into the Spatial Editor panel. And you can see we've got some tables on the right here that shows the individual shapes, what attributes are available, and also the coordinates and Z values, if there are any. So I'd like these faults to have a name, a meaningful name within ArcMap as an attribute. And I can do this by going to the Layers menu and choosing the definition. So there aren't many attributes in here just now. I can add in as many as I want to, but I'll add in a new attribute for the surface. And this can be different types. This particular one is going to be text. We won't go into these other options in detail, but notice this is also where you get access to operations for shapes, so you can do things like buffering as well as back interpolation. So I've got my new attribute in here. It's blank for all of these items. We know they're all top edit surface, so if we just select them all at once, we can go in here and edit the surface name. That's us. Each of these faults has now correctly got the surface associated with it. The other thing I might be interested in doing is making the ends of the faults a bit more geologically realistic. There are some excellent editing tools within the Spatial Editor that are very quick and easy once you get the hang of them. You could drop a part out and redigitize, or if you want to keep things like the z-values, just edit the vertices themselves. So we've got a few vertices there, just pull this one out, and that one was a mistake, so we'll just delete it again. But that's a better looking end to our fault. When we're happy with the edits we've made, we can just save this back to our live shapefile. And when we go back into ArcMap again, we can now just go to View, Refresh, and you'll see we've got the edits to the shapes themselves appear immediately. I can also use the query tool and just look at the individual values, and you can see we've now got the attribute written in for the top etif. That's the end of our live demo. Just a reminder that you can always look for more information about Petrosys and its connectivity with other applications through the workflows that are available on our client portal, or else please contact our support. Thank you very much for your time today. I'll now have a look at the chat log.